The moon's gravitational pull causes the ocean's water to bulge, resulting in approximately 671 trillion gallons of water moving every 12 hours and 25 minutes, which is the average time it takes for the Earth to rotate relative to the moon's position. This phenomenon affects approximately 71% of the Earth's surface, which is covered by oceans. The moon's effect on ocean tides is crucial for navigation, fishing, and coastal management. For instance, the difference between high and low tide can be as much as 50 feet in some areas, such as the Bay of Fundy in Canada. Here's why that matters. The moon's mass is approximately 1% of the Earth's mass, which is sufficient to cause a noticeable effect on the ocean's water. The moon's gravitational force causes the ocean's water to accelerate towards it at a rate of approximately 1.1 millimeters per second squared. This force is stronger on the side of the Earth facing the moon and weaker on the opposite side, resulting in 2 high tides and 2 low tides every 24 hours and 50 minutes. The moon's orbit is approximately 239,000 miles away from the Earth, which is close enough to have a significant impact on the ocean's tides. The sun also has a gravitational effect on the ocean's water, although it is about 46% of the moon's effect due to its much larger distance from the Earth. The moon's gravitational force causes a tidal force, which is a difference in the gravitational force between 2 points. The tidal force is responsible for the ocean's water bulging out in 2 areas, one on the side of the Earth facing the moon and the other on the opposite side. The strength of the tidal force depends on the distance between the moon and the Earth, as well as the mass of the moon. The tidal force is also affected by the Earth's rotation, which causes the ocean's water to bulge out in 2 areas. The combined effect of the moon's gravitational force and the Earth's rotation results in the rise and fall of the sea level, creating high and low tides. The amplitude of the tides can be affected by the shape of the coastline, the depth of the ocean, and the wind. The tidal patterns are more complex than just the simple rise and fall of the sea level. The Coriolis force, which is caused by the Earth's rotation, deflects the moving water to the right in the northern hemisphere and to the left in the southern hemisphere. This deflection results in the formation of tidal currents, which can be strong enough to affect navigation. The tidal patterns can also be affected by the resonance of the ocean's water, which can amplify or dampen the tidal forces. For example, the tidal range in the Gulf of Mexico is amplified by the resonance of the ocean's water, resulting in a larger difference between high and low tide. The complexity of tidal patterns makes it challenging to predict the tides accurately, which is essential for navigation, fishing, and coastal management. The moon's effect on ocean tides has a significant impact on the Earth's ecosystem. The tidal forces help to mix the ocean's water, which is essential for the distribution of heat, nutrients, and marine life. The tidal currents also play a crucial role in shaping the coastline, creating estuaries, and forming marine habitats. The tidal patterns can also affect the climate, as the movement of the ocean's water helps to distribute heat around the globe. For example, the tidal mixing in the North Atlantic Ocean helps to moderate the climate in Western Europe. The moon's effect on ocean tides is also essential for human activities such as navigation, fishing, and coastal management. The accurate prediction of tides is critical for the safety of ships and the protection of coastal infrastructure. Tidal energy is a promising source of renewable energy, which can be harnessed using tidal barrages or tidal stream generators. The tidal barrages, such as the one in La Rance, France, can generate up to 240 megawatts of electricity, which is enough to power approximately 200,000 homes. The tidal stream generators, such as the ones used in the Pentland Firth, Scotland, can generate up to 10 megawatts of electricity per turbine. The tidal energy has the potential to provide a significant portion of the world's electricity, especially in coastal areas with high tidal ranges. However, the development of tidal energy is still in its infancy, and more research is needed to overcome the technical and environmental challenges. The prediction of tides is a complex task that requires accurate models of the ocean's water and the tidal forces. The tidal predictions can be affected by various factors, such as the wind, the atmospheric pressure, and the ocean's currents. The accuracy of tidal predictions is essential for navigation, fishing, and coastal management, as incorrect predictions can result in significant economic losses and even loss of life. However, the development of accurate tidal models is challenging due to the complexity of the ocean's water and the tidal forces. The use of advanced technologies, such as satellite altimetry and ocean modeling, can help to improve the accuracy of tidal predictions. In conclusion, the moon's effect on ocean tides is a complex phenomenon that has a significant impact on the Earth's ecosystem and human activities. The accurate prediction of tides is essential for navigation, fishing, and coastal management. The development of tidal energy is a promising area of research that can provide a significant portion of the world's electricity. Subscribe for more deep dives.